क्वेश्चन नंबर 16, इनमें से कौन से स्टेटमेंट्स गलत हैं? यूनिट ऑफ एटमॉस्फेरिक प्रेशर एंड दिस इज pi and p, which is atmosphere, that's fine. Reverse osmosis, solid molecule move through a semi-permeable membrane. Okay, sure. From a region of lower concentration of solute to a region of higher concentration of solute. ये let's analyze this a little bit. लग रहा है confusing, but whether सही है गलत है देखते हैं. Same चीज़ आप करिए, do this U-tube sort of a setup. यहाँ पे है आपका semi-permeable membrane. And remember कि अगर इस तरफ जो है ज़्यादा कॉन्सेंट्रेटेड है और इस तरफ लेस कॉन्सेंट्रेटेड है तो सॉल्वेंट फ्लो इस डायरेक्शन में होगा, क्योंकि इसमें सोल्यूट नहीं जा सकता है, राइट? ओनली सॉल्वेंट कैन फ्लो. सो यहाँ पे सोल्यूट की कॉन्सेंट्रेशन नहीं है, यहाँ पे सिर्फ सॉल्वेंट है इस तरफ, राइट? एंड दिस इज बोथ सोल्यूट प्लस सॉल्वेंट, मतलब कि यहाँ पे सोल्यूशन है. तो सॉल्वेंट की कॉन्सेंट्रेशन कम है राइट हैंड साइड में, तो उसको जो है नॉर्मलाइज करने के लिए सॉल्वेंट फ्लोज फ्रॉम लेफ्ट टू राइट. ओके, नाउ यहाँ सवाल में क्या दिया है? इन रिवर्स ऑस्मोसिस. अच्छा, ये तो ऑस्मोसिस हो गया. रिवर्स ऑस्मोसिस मतलब P ग्रेटर देन पाई, तब उल्टा डायरेक्शन हो जाएगा, राइट? व्हेन P इज ग्रेटर देन पाई देन दिस, एंड देन व्हेन देयर इज नो प्रेशर अप्लाइड, और इफ P इज लेस देन पाई, P मतलब यहाँ पे अप्लाइंग प्रेशर P. तो ये भी सही लग रहा है. काफ़ी टाइम लग गया हम लोग को फॉल्स करने के. ओके, रिवर्स ऑस्मोसिस, सॉल्वेंट मॉलिक्यूल्स मूव फ्रॉम थ्रू अ सेमी-परमेबल फ्रॉम रीजन ऑफ लोअर कॉन्सेंट्रेशन. नहीं, उल्टा हो जाएगा इधर, है ना? इस केस में हायर कॉन्सेंट्रेशन हो जाएगा. वी जस्ट सॉ दिस, हायर टू रीजन ऑफ लोअर कॉन्सेंट्रेशन. दैट्स द होल पॉइंट ऑफ रिवर्स ऑस्मोसिस. मैंने आपको यहाँ पे डायग्राम बना के दिखा दिया. खैर, द वैल्यू ऑफ मोलर डिप्रेशन कांस्टेंट डिपेंड्स ऑन नेचर ऑफ सॉल्वेंट. या एब्सोल्युटली, ये वाला सही है, हेंस नॉट आवर आंसर. Relative lowering of vapor pressure is a dimensionless quantity. Yeah. Delta P by P, dimensionless equal to mole fraction, etc. Hence not the answer. 2 should be the answer. Yeah, ये वाला सवाल थोड़ा सा टाइम सिंक था for sure. Value of Henry constant KH increases with increase in temperature, decreases with increase in temperature. Okay. अगर KH की वैल्यू बढ़ेगी तो क्या होगा? वेल, टेम्परेचर बढ़ेगा तो KH की वैल्यू बढ़ेगी घटेगी? डू यू रिमेंबर दिस? टेम्परेचर बढ़ने पे डज अ गैस डिजॉल्व मोर इजीली और लेस इजीली? दैट्स द इजीएस्ट वे टू फिगर दिस आउट. एंड रिमेंबर, वी आर लुकिंग एट द फॉर्म ऑफ दिस एज P इक्वल टू KH टाइम्स X. हम लोग इस टाइप का इक्वेशन ले रहे हैं. इन सम बुक्स, नॉट इन NCERT बट और दूसरी बुक्स में, you have another form of the equation where you say that KH times P equal to X. We are not doing that right now. हम लोग NCERT पे फोकस कर रहे हैं. Okay. Now इस इक्वेशन में मैंने टेम्परेचर बढ़ाया तो गैस कम डिजॉल्व होती है. हाउ डू रिमेंबर दिस? वो कोल्ड ड्रिंक वाला एग्जाम्पल होता है ना, कि सोडा जो है जब ठंडा होता है तो ज़्यादा डिजॉल्व होता है, गर्म होता है तो इट गोज फ्लैट. उसी से गर्म हो तो मतलब सॉल्युबिलिटी कम हो गई. अगर सॉल्युबिलिटी कम हो गई यानी कि X कम हो गया, मतलब कि KH बढ़ गया. तो सही वाला पहला ही लग रहा है मुझे. इंक्रीजेज विद इंक्रीज इन टेम्परेचर, सॉल्युबिलिटी कम हो जाती है गैस की जब टेम्परेचर बढ़ता है. ओके, एक और वैल्यू ऑफ हेनरी कांस्टेंट, हेनरीज कांस्टेंट KH पे, ग्रेटर फॉर गैसेस. अब देखिए, इसमें भी हमने आंसर कर दिया ऑलरेडी. ग्रेटर फॉर गैसेस हाई सॉल्युबिलिटी, नो, इट इज हाई, द वैल्यू इज हाई जहाँ पे जो है कोई गैस होती है जिसका सॉल्युबिलिटी कम होती है. दिस इज द राइट आंसर. कांस्टेंट ऑल गैसेस डजंट मेक सेंस, नॉट रिलेटेड सॉल्युबिलिटी, डमी ऑप्शन. ऑस्मोसिस पे सवाल. 8 PM. ओके, ये क्या है? ठीक है, देखते हैं. Is it supposed to be S, like a semi-permeable membrane? I think so. What is 8 PM? खैर, यहाँ पे concentrated NaCl है. This is exactly the same as जो मैंने ऊपर बनाया था, या this sort of a thing, जहाँ पे ज़्यादा concentrated है, इस तरफ सिर्फ pure solvent है. This is exactly the same situation. मतलब कि अगर this direction is osmosis naturally, and उल्टे डायरेक्शन में रिवर्स ऑस्मोसिस if and only if P is greater than pi. Okay, now that we've already analyzed this, let's see. Now हम लोग आराम से ऑप्शंस पढ़ेंगे. Water will move from side A to side B if pressure is lower than atmospheric pressure, lower than osmotic pressure applied on piston B. यार मुझे तो यही सही लग रहा है. Okay, water will move from side A to side B if a pressure lower than osmotic pressure is applied on piston B. हाँ, सही लग रहा है. What about the next one? Water will move from side B to side A if pressure greater than osmotic. ये भी सही लग रहा है यार. ये क्या हो गया? ये तो this is reverse osmosis है ना. Water will move from side B to side A if a pressure greater than, yeah, this is reverse osmosis. हाँ, वाटर मूव फ्रॉम ए टू बी इफ प्रेशर लोअर देन, यार मुझे तो दोनों सही लग रहे हैं, ये तो सिंगल करेक्ट होना चाहिए. We'll see. Water will move from side B to side A if pressure equal to, no, obviously, if the pressure equal to osmotic, when P is equal to pi, then there is no movement, है ना, movement नहीं होगा. Water will move from side A to side B if pressure equal to, हाँ, these are dummy options. अगर pressure equal है, तब तो movement नहीं होगा ना, that's the point. That's the definition of osmotic pressure. The exact pressure required to stop osmosis, है ना. अगर ये theory नहीं मालूम है तो मेरा वीडियो देख सकते हो, either on Byju's or on Khan Academy, wherever you like, but the idea is the same, or just read a book. Let's read 1 and 2 एक बार just to make sure, क्योंकि ये वाले सवाल तो एक सही होने चाहिए ना. Water will move from side A to side B if pressure lower than atmospheric pressure, osmotic pressure applied on piston. हाँ यार, ये भी सही लग रहा है मुझे, कोई गलत बात तो नहीं है इसमें. Naturally लेफ्ट टू राइट जाएगा, थोड़ा प्रेशर डालोगे राइट साइड में तो थोड़ा धीरे जाएगा, बट इट विल कीप फ्लोइंग अंटिल यू अप्लाई द प्रेशर इक्वल टू ऑस्मोटिक प्रेशर. ये दोनों सही लग रहे हैं, चेक कर लेना. We have 3 aqueous solutions of NaCl labeled as ABC with concentrations blah blah blah. The value of Van't Hoff factor, well, तीनों का same ही होगा. Van't Hoff factor is not going to change from concentration, is it? Right? It's, well, technically it doesn't. I know that there is another table in NCERT that says differently. अगर पूरा dissociation नहीं हुआ तब कुछ अलग अलग चीज़ होती है. Then इसका Van't Hoff factor सबसे ज़्यादा होगा, इसका थोड़ा सा कम और इसका will be the least. But here we are assuming full dissociation, and only then can you answer this. Otherwise, ulta bhi ho sakta hai. You know how JEE main is these days. So yeah, if you see this question JEE main, mark this. I don't want to be teaching things like this, but sadly आजकल इतना theoretical हो गया है JEE main को. अगर exact सवाल NCERT से आ रहा है, mark it, get marks. Don't use your brain. Sad but true. I hope it changes. खैर, on the basis of information given here, mark the correct option. यार ये तो बहुत बड़ा सा सवाल हो गया. Okay, A, B, C. Okay, what do we have to do here? Raoult's law follow करता है, नहीं करता है. अच्छा, follow करता है. Negative deviation, positive deviation. मतलब कि we are talking about volatile solute and solvent. दोनों चीज़ volatile है, ठीक है. I know you haven't dealt with volatile solid as such, but हम लोग इसलिए बोल सकते हैं liquid, but solid volatile भी हो सकता है. खैर, not in our syllabus, don't worry about it. Okay, bromoethane, chloroethane. This looks like this is true. Yeah, this is what do you call this? Ideal solution. This is an ideal solution. तो ये तो Raoult's law follow करेगा. अब just with that idea, you know that 2 is the answer because nowhere else does it show. Actually नहीं. 3. Yeah, 2 is correct and single correct है तो हो सकता है. But let's just check because पिछले वाले में गड़बड़ी हो गई थी इनके हिसाब से NCERT से. In ethanol and acetone mixture, AA and BB type intermolecular interaction are stronger than AB. Well, यार ये तो सही है. Okay, B is correct, but B shows positive deviation. Gotta write that here separately. Oops, ये क्या हो गया? Positive deviation. That's going to be B right here. यहाँ लिखा है negative deviation तो गलत हो गया. What about C? Chloroform or acetone. ये भी NCERT का डायरेक्ट एग्जाम्पल है. पानी के साथ the hydrogen and not water, sorry, O and H, there is hydrogen bonding that happens. So this is going to be negative deviation. Boiling point will be higher. That's not what this is saying. So there you go. And of course B and C won't follow Raoult's law because there's a deviation which we've just spoken of. 2 beakers of capacity something बड़ा सा सवाल. Let's short circuit it. NaCl है, water है, osmotic pressure की बात हो रही है क्या? नहीं, वेपर प्रेशर की बात हो रही है. Okay, so देखिए इसमें NaCl है. That means there is lowering of vapor pressure which is going to be equal to the mole fraction of NaCl in this. Okay, with that can we answer this? Do we have to read this whole thing? ये बड़ी बड़ी चीज़ें लिखी हैं यहाँ पे. सेम ही पानी तो सेम है, ठीक है. I don't think I have to read that. I did quickly. You can read it also if you want. But clearly vapor pressure of A is going to be greater than that of B. Is less? No, because this is pure solvent. मेरे हिसाब से यहाँ पे भी 20 सेकेंड वाले में 1 आंसर होना चाहिए. What do you think? सोच के बताइए. Leave answers in a comment if you want, if you feel differently. Vapor pressure is equal. That's not true. There is clearly a reduction, relative lowering of vapor pressure that happens over here. No, it is twice. Wow, okay, that's new. It's not more, it's lower. We can calculate how much, but we don't have to because It guesses the answer. Okay, if two liquids A and B form minimum boiling point azeotrope at some specific composition, then clearly AB interactions are stronger than those between A. Yeah. This is also पहला वाला सही बोल गया, हाँ लग रहा है. Vapor pressure solution A increases. Because more number of molecules of liquid A and B can escape from solution. Well, this would happen if you had wait. Vapor pressure of solution increases because more number of molecules liquid of A and B can escape from solution. This is an interesting point, right? Minimum boiling point azeotrope at some specific composition. Well, that's a definition of minimum boiling azeotrope, that it happens at a specific composition. And ये one भी true है, two भी मुझे ठीक ही लग रहा है. There's nothing wrong with two. Vapor pressure of solution increases because more number of molecules liquids of A and B can escape from solution. Yeah, that's exactly why. Vapor pressure of solution decreases. No, if the vapor pressure decreases, then you need a higher temperature for the solution to boil. That would mean a negative deviation and a higher boiling point. AB interactions are weaker than, yaar ye bhi sahi hai. AB interactions are weaker, minimum boiling. What? Dude, what is happening here? Are you supposed to find the one that's not correct? That doesn't make any sense to me. If two liquids, just going to read it one more time. If two liquids A and B form minimum boiling azeotrope at some specific composition, then AB interactions are stronger than between A and AB. BB, yeah, that's the definition, right? And itna zyada ho jata hai interaction. Wait, AB interactions are stronger. No, ये तो गलत है. Huh. AB interactions are stronger. No, AB interactions are weaker. What are we doing? Minimum boiling azeotrope. That would be maximum actually. अगर ये होता तो ये उल्टा कर दिया. Apologies for that. Good to recheck always. Vapor pressure of solution increases because more number of vapor. Yeah, this sounds good to me. So 2 and 4 are both that sound good to me. I'm not sure. Yeah, I'm sure about 1 and 3 not being correct. So I'm not sure how come they are 2 correct, but we'll revisit it if we need to. This question specifically. 4 liter of 0.2 molar aqueous solution of NaCl was diluted by adding 1 liter of water. The molarity of desired solution is blah blah blah. Do we need to solve this? Yeah, I think this is very easy to solve. तो idea क्या है? Molarity की definition लिख लीजिए. Mole solute divided by mass of solvent in kilogram. इसमें मोल कितने थे? 4 into 0.02, right? 4 liter into 0.02 molar. और मास क्या है सॉल्वेंट का किलोग्राम में? 1 और लीटर ऐड कर दिया है, तो हो गया 4 किलो प्लस 1 किलो प्लस whatever that mass was, right? 0.02 into, I don't think I will do this. कितना हो गया? 23 for sodium plus 35.5. It's a really, really small number. I don't think we have to worry about this. So let's just ignore this. So it becomes 4 by 5 into 0.02. That's my analysis. What do you think? Yeah? The answer, my friend, is 0.016. चलिए आगे बढ़ते हैं. On the basis of information given below, mark the correct option. Information. Adding acetone to methanol, some of the hydrogen bonds between methanol molecules break. बिल्कुल सही. A specific composition of methanol acetone mixture will form minimum boiling azeotrope and show positive deviation from Raoult's law. Well, that's interesting. Acetone and methanol. Some of the hydrogen bonds break. Acetone, methanol. Yeah. So, does it form an azeotrope? 25 is talking about azeotropes, huh? At specific composition, ethanol will form minimum boiling azeotrope and show negative deviation from Raoult's law. Okay, so it talks about positive and negative deviation. Okay, I have a feeling that this deviation is definitely positive. Okay, so we're going to cut out these two. Why am I confident about this positive deviation? We are saying that we are disrupting methanol molecules के hydrogen bonds, which means that it's easier for these molecules to now escape into the vapor phase. So positive deviation from ideality. Okay. अगर positive deviation हो गया, then it must form a minimum boiling azeotrope. I'm not sure if it forms azeotrope or not, but looking at these options, there is only one that fits. 25-1. All right. Last question for this MCQ bit. KH value for all of these are given to you. Arrange gases in the increasing solubility. सबसे ज़्यादा solubility किसकी होगी? इस भाई साहब की. कौन सा? अच्छा नहीं, there is one smaller than that. This chap right here, HCHO should have the highest solubility. Yeah, you see that right away? Okay, awesome. The next one would possibly be ये वाला. ये कौन सा है? Methane. Yep. This is the answer to this one right here. चलिए मोर देन वन करेक्ट वाले को देखते हैं अब. इसमें से कौन सा फैक्टर है जो solubility of a gaseous solute in the fixed volume को इफेक्ट करता है of liquid solvent? Okay, pressure for sure. Nature of solute? Yeah, I think so. No, well, number of solute, number of particles, right? That was the whole point of colligative stuff. It's not the nature, but number that matters, right? That's what we studied all this time. But which of the following affects solubility? Oh, we are not talking about pressure. We are not talking about the whole relative loading and any of those things. We are just talking about solubility now. So nature of solute, यानी कि if I have got, say, well, CO2, that could be a solute. Or if I got SO2, that's a solute. CH4, that's a solute. All of these are solutes. Gaseous solute likha hai, right? In the fixed volume of liquid solvent. So yeah, number of particles, colligative properties and all is good, but that's not what we're talking about here. We're talking about gas being dissolved in a liquid. So nature of solute definitely matters. Yeah, so whether CO2 hai, SO2 hai, CH4 hai, it may have some bonding that may help with the dissolution. Temperature पे matter करता है, pressure पे matter करता है. So you keep one thing constant, these two are dependent. Keep the other thing constant, these two are dependent. Hence 1 and 2 are correct. Yeah, be careful over here. I know you can be in a hurry and say कि B and C only and not A, but you see why we have just discussed कि ये वाला होना चाहिए. Okay. Intermolecular forces between two benzene molecules are nearly of same strength between two toluene molecules. Okay, ठीक है. तो Raoult's law would be followed. Ideal solution for a mixture of benzene and toluene which are not true. ये सही है, ये सही है. Hence not the answer, right? Delta H mixing, delta V mixing 0. This is a definition of an ideal solution. These form? No, of course not. These will not form. These will form an ideal solution. We just identified that. 28 will be just these two that are wrong. The last two. Okay. RLBP is a colligative property because it depends on concentration of non-electrolyte solution, depends on number of particles, depends on concentration of non-electrolyte, depends on concentration, ठीक है. Nature, no, it does not depend on nature of solute as well on nature, does not depend on nature. Does not depend on nature. Okay, I like this one. I like 29.2. What about one? Depends on the concentration of non-electrolyte. हाँ ठीक है. Electrolyte, non-electrolyte दोनों के लिए काम करता है. This works for sugar and it works for NaCl. You just need to find out NaCl जब dissociate करता है, is it giving me how many moles of ions is it giving? Number of particles, right? So 1 and 2 are both correct. Awesome. Van 't Hoff factor is given by expression. Observe colligative property by calculated. All right. Observe. Is the same thing written twice? Oh no. No, that's not right. Abnormal mass? No, it's normal mass. Why? Because look, what is molar mass? It is given mass divided by moles. Right? That's the molar mass. So if moles is in the denominator, so what you need is moles final by moles initial, right? That is proportional to I, or actually equal to I in fact, right? So that happens here because observe colligative property will be I times, you've got this one figured out. I'm not going to bug you about this. This is clear. What you actually get by what you had calculated, what you're supposed to get. So 33 I hope is clear. 31 should make sense. Go through the theory if you like. But you want moles of final on top, moles initial at the bottom, right? That's what I value is. But by definition, this is the other way around. So don't put observed or abnormal molar mass on top. If you do that, your final moles will go to the denominator, but you want the final moles on top, okay? Take some examples if you're not sure about this. These are the two correct ones here. Isotonic solution must have the same, yes, same solute, no, same density. That's interesting. Does density have anything to do with anything? That's interesting. Density 31 is must have the same density. Okay, let's see. pi equal to CRT. Okay, all right. If they have the same if they have the same pressure, right, osmotic pressure, will they have same elevation boiling point, same depression freezing point? I'm inclined to say yes, but what does pressure have to do with freezing? Pressure, yeah, all right. Elevation and boiling point, I can make that work, because you know how it is, right? When pressure is equal to the atmospheric pressure, that's when boiling happens, right? So I can say with confidence that elevation and boiling point, if both have the same pi, that works. What about density? Do you remember this? P equal to dRT by M. Do you remember this definition? I mean, not in definition. PV equal to nRT. What do we do then? Okay. P equal to N by V RT. Okay. Then what? Then write this down as mass divided by molar mass. Right? That's what moles is. Mass divided by molar mass. Times V times R times T. Now this right here is your density. Right? So P equal to D RT by M. This is something you probably know from gaseous state, but if you haven't studied it, simple, quick derivation. So, if two things have the same pressure and, well, they have the same density only and only if the solute is the same and the temperature is the same. So, this one's a little tricky. I'm confident about 3. I'm not so sure about 4 or 2. Isotonic solutions obviously did not have the same solute, but we are saying the same thing about density as well. So think about this, and you can, push this and say, you know what, if I have the same molar mass, then yeah, all right, cool. If they have the same molar mass, then the density is the same. So this one's a little bit of a tricky question, I feel. Which of the following binary mixtures will have same composition in liquid and vapor phase? Same composition in liquid and vapor phase. That happens if you have an azeotrope, right? Minimum or maximum boiling, doesn't matter, but azeotrope. This one an azeotrope, this one an azeotrope. Yeah. Do you know the concentration, the exact concentration? Something like 69 was for nitric acid, 63 or 69, something like that. Water ethanol was what? 95.5? Yeah, figure it out. This is in the text book itself. This is an ideal solution, which means it has different compositions, in the liquid and vapor phase when it boils. It makes sense, right? When I'm not going to go into theory. I'm tempted, but I won't. Check the theory out. Yeah. These two will form azeotropes. In isotonic solutions, solute and solvent both are same. Nah. Osmotic pressure same? Yes. Solute and solvent may or may not be same? Yes. Solute always same? What? No. 2 and 3 is what I want to go with 33. This is definition stuff. For a binary ideal liquid solution, the variation in total vapor pressure versus composition of solution is given by which of the curves? Binary ideal liquid solution. Variation in total vapor pressure versus composition of solution. If it's ideal, it should be a straight line. Okay, I've got 2 straight lines. Are they both the answer? Well, sure. I mean, it depends on what 1 and 2 are, right? This is just saying that this is P01, this is P02. And in this case, here lies P1 naught, here lies P2 naught. So it depends on which one's 1 and 2, right? What kind of liquids you take. It could be both of these. Yeah. In one case, P1 naught is lower than P2 naught, the other case P1 naught. I mean, it just depends on how you define 1 and 2, to be honest. So 34th, I feel, should be 1 and 4 as well. 2 of these are correct. Okay. Colligative properties are observed when a non-volatile solute dissolved in a volatile liquid. Perfect. Non-volatile liquid is dissolved in another volatile liquid. Oh, we haven't seen such examples. Oh, wait, of course we have. Yeah. Benzene, toluene, etc., etc. No, a non-volatile liquid. What's a non-volatile liquid? Hold on. Well, whatever it is, if it exists, must be true. Gas dissolved? No, this is volatile. No, this is volatile. If you have solute that's volatile, does not work. You can figure the short answer, long answer stuff by yourself. Column, let's see. Is there something more fun left for us to do? Assertion, reason. Oh, yes, let's do these. Let's look at some assertion, assertion, reason, questions, just 3-4 of them. Molarity of a solution in liquid state changes with temperature. Yeah, absolutely, because depends on volume, right? Oh, that's the next one. The volume of solution changes. All right, this one's 1. Let me write 1 over here. Okay. What do you think? I'm quite confident about this. When methyl alcohol is added to water, boiling point of water increases. No, I don't think so. Does it increase? I feel it decreases because this has hydrogen bonding and you're disrupting that, right? So this statement is false. Assertion is false. Assertion is false. Okay, so it's either 4 or 5, not 1, 2, 3. When a volatile solute is added to a volatile solvent, elevation and boiling point is low. Whoa, no. When a non-volatile solute is added to a volatile solvent, then you know for sure there's elevation boiling point. Otherwise, boiling point could be higher, lower. Depends. So this one is going to be, they're all wrong. Both of these are wrong. Number 4. NaCl is added to water, depression freezing point is observed. Sahi jawab. Yeah, this works. Lowering of wave pressure solution causes depression freezing point. Absolutely. If you've seen my videos on Khan Academy, I have defined RLVP, not defined, I've used RLVP to be the cause. Relative lowering of vapor pressure is the cause. And what's the effect? Well, everything else. You have delta TF, delta TB, pi, etc., whatever else. Okay, last one. Oh, this one's 1? Yeah, this one's 1. 54, question number 54. When a solution is separated from the pure solvent by a semi-permeable membrane, solvent molecules pass through it from pure solvent side, solution side. Yeah, this is osmosis. This is because, well, solute particles can't pass through. Only solvent particles can pass through. There's a concentration difference and liquid flows. Diffusion of solvent occurs from a region of high concentration solution to region of low concentration. Wait, hold on now. This is confusing. This is true. Diffusion of solvent occurs from a region of high concentration. Okay. This is true, but technically, I'm divided between 1 and 2 because यहाँ पे देखिए ये सही कारण है, but I could argue that the reason for this to happen is because I have a semi-permeable membrane which does not allow solute to flow through. Because solute नहीं flow कर सकता है, because and इसीलिए solvent flow करता है, उसका कोई चारा नहीं है. That could be an argument and hence I can say 2 is the answer. Or I can say ये तो सही कारण है. This is the right reason for the liquid to flow because it flows from a high concentration from a low concentration. So a little bit tricky. I'm leaning towards 2 because 1 would require that this is the only reason. This is something that always happens. But this only happens in a semi-permeable membrane. But we यहाँ पे दिया हुआ है सवाल में. Bit confusing. I feel it should be 1 actually then though. Nah, I'm divided. What do you think about this one? Let me know. And your answer key says it's 2, but I'm inclined towards 1. If semi-permeable membrane नहीं लिखा होता, then I would be like, interesting. All right, English ka khel. But that was it from me on the chapter of solutions.